How do we deal with polar equations of conics using eccentricity? Well, what does it mean to have a polar equation with eccentricity? Well, here is a polar equation of conic sections, and we can describe a number of different conic sections with this. We could describe an ellipse. We could describe a hyperbola. We could even describe a parabola. With this. So this formula describes a conic section with orientation horizontal, a focus at the pole, and E is greater than 0 as the eccentricity. So that's E, that's E is the eccentricity, it's not E the number. P we're not going to worry about, but it is the same P as in 4P in a parabola. You'll notice that this one is cosine, matches with a horizontal orientation. Everything on this slide stays the same to this slide except for sine and a vertical orientation. So this would look like, this could look like a hyperbola, like that. It could look like an ellipse like this, or a parabola like that. Whereas these would be horizontal, like that, or like that. So the way we're going to write a conic with eccentricity in rectangular form, multiply both sides of the equation by the denominator, because each of these had theta in the denominator. Convert r sine theta or r cosine theta to y or x. Then we will solve for r, square both sides, and replace r with x squared plus y squared. So let's write this one in rectangular form. The first idea is to multiply by 1 minus 0.7 sine theta. So if we do that, we get r minus 0.7 r sine theta equals 2.1. Now, r sine theta is the same thing as y. Getting r by itself, r equals 0.7y plus 2.1. I'm going to do this out of preference, but you don't have to. I'm going to write this as 0.7y plus 3. And now we can square both sides. Squaring both sides gives r squared equals 0.7 squared is 0.49. And y plus 3 gets squared. And now we have, this is x squared plus y squared equals 0.49 y plus 3 squared. Now, if we wanted to write this, if we wanted to continue this, we could go further to write it in general conic form or write in standard form. This is enough information to figure out that this is an ellipse. Graph this. So we're going to first want to solve. We multiply by the denominator. So we get r plus 3r cosine. And then this becomes x. So r equals negative 3x plus 6. So r equals negative 3x minus 2. Squaring both sides gives x squared plus y squared. X equals 9 times x minus 2 squared. Because we want to graph this, we need to rewrite this. So x squared plus y squared equals 9 times, this gets multiplied out as x squared minus 4x plus 4. Distributing x squared plus y squared, 9x squared minus 36x plus 36. Getting everything on the left side gives y squared minus 8x squared plus 36x equals 36. We need to factor out a negative 8. x squared, this is minus 36 divided by negative 8. Well, 36 divided by 4 is 9, so 9 halves. Now we need to add something to both sides. So this is going to be adding half of that is 9/4, squared is 81/16. 81/16, I'm multiplying that by negative 8 to get 81 halves. So plus 81 halves, which is 40.5. Actually, minus 40.5. So y squared minus 8 times x minus 9/4 squared equals, let's see, this is negative 4.5. Now divide by negative 4.5, and we get y over negative 4.5. And then this is x minus 9/4 and 4.5 divided by 8. So that gives us a sense of where the center is. The center is at 9/4. 9/4 is there. We know that the focus is here, and then the other focus is going to be an equal distance over there. And then we can use that to find what the hyperbola is approximately. That's a reasonable approximation of the hyperbola.